to Math 155, section 4.1. In this lecture video, let's take a look at proportion. So proportion is consists of two sets of rates or comparing between two ratios. All right. So normally when we're talking about proportion, okay, we always have a ratio, a rate set equal to another rate, or this can be a ratio set equal to another ratio. All right, it's basically comparing between two ratios or comparing between two different rates. Together, we can set them up as proportional equation. So when we normally solve proportion, we use this technique called the cross product. So cross product says for any real number A over B is set equal to C over D, which what you see here is two terms equal to each other. And specifically, these two terms are both containing fractions. So whenever you see that, what you can do is multiply them diagonally. All right. So that will be A times D, which will be AD. Okay. A times D is AD, and we'll set it equal to B times C, which will be BC. Okay, that's the way we actually set them up, and then we can solve for our variable accordingly. All right, so let's take a look at see if we can read these word problems here and set them up as proportion. All right. Let's say an entry-level programmer annual pay is $56,316 based on 52 weeks per year. Due to the economy, his company is having to cut back on the number of weeks that it employs its programmers. If the firm cuts the work year to 49 weeks but keep the same rate of pay, right? How much should the programmer expect his annual pay to decrease? All right, so what that means is, this right here, the rate of pay is basically saying pay them the same amount per hour or per week, but we cutting back from 52 to 49 weeks. So basically you lose about 3 weeks of work in a year. So normally when we set up proportion word problems, we want to put the numbers with the same meaning or the same unit. Top to top, same meaning or same unit. And another two sets of number with the same meaning and the same unit, put them bottom and bottom side by side. Okay. This is just one way to set up the proportion. So right now I have a $56,000. So the $56,000 316 is for 52 weeks of work. All right. Now we're going to set it equal to X number of dollar per year, but it's only for 49 weeks. So you see how I put the two number weeks in the bottom side by side, put my $2 amount on the top side by side. I can put my $2 amount in the bottom side by side, put the 2 weeks up top. It doesn't really matter. But one thing that's important to notice is the 56,000 go with the 52 weeks, so they got to be in the same fraction together. Now, if I would put 49 weeks right below the 56,000, then that will actually throw me off. Okay, so the rate I'm starting out with is 56,000 for 52 weeks. So that's why they are together in the same fraction. All right, so let's use a little cross product. We take the 52 weeks times X amount of dollar. 52 times X is 52X. Set equal to, multiply diagonally, 56,316 times 49. Let's see, 56,316 times 49. So that will give me 275 9484. All right, divide both sides by, so I only got two terms here, so all I'm going to do is divide both sides by my coefficient. So this is basically setting up as proportion and solve for x. Now, if you like to do a different way for this problem, that would be fine, because there are different ways to, students use different techniques when it comes to solving for proportion. Oh, sorry, my markers. Let's see. 2,759,484 divided by 52. Okay, that would be $53,067. Oh, sorry, I'm freeze a little bit. Here you go, 1 second. Pen, sorry about that. My pen is freezing up. $53,067. So that will be his pay for the 49 weeks. Okay. All right. Let's try another one. A sugar cookie recipe makes 3 dozen cookies. Calls for 1.5 teaspoon of baking powder. How much baking powder would you need to make 2 dozen? Okay, so this is a perfect example for proportion. So 3 dozen cookies. So the 3 means dozens cookie for 1.5 teaspoon of baking powder. All right. So what happens if I only need to make 2 dozen? So the rate is 3 dozen cookie for 1.5 teaspoon. So 2 dozen for how many? Okay, teaspoon of baking powder. So that would be X right here. So if I use another cross product, so 3 times X is 3X, that equal to 2 times 1.5, which is 3. Divide both sides by 3. My answer, X equal to 1. So that means for 2 dozen cookies, I only need what? 1 teaspoon of baking soda. All right. This is an interesting problem. You're making dessert, but your recipe needs adjustment. Your chocolate chip cookie recipe makes 4 dozen cookies, but you need 3 dozen cookies. If the recipe required this much cups of butter, this many teaspoons of baking powder, this many cups of pecans, how much of each of these ingredients are necessary for 3 dozen cookies? All right. So 3 dozen cookies. So these numbers are for 4 dozen cookies. I only need to make 3 dozen. So that's actually 3/4. Okay, of what? So all my recipe now becomes 3/4 of what I normally need. Okay, I hope that kind of makes sense, because this is actually for 4. So to make 3 out of the 4, that's 3/4 of it. So I need to figure out my recipe for only 3/4 of what I normally use. Okay, so let me just try one. Okay, let me try one. Let's take 1 2/3 cup of butter, right, times by 3/4. Let's try it this way. Okay, then I'm going to set up as proportion for you. So as you can recall, to enter mixed number in my particular graphing calculator, I got to say parenthesis 1 plus 2 divided by 3, close parenthesis, times by 3/4, because I need to put my mixed number in a parenthesis for the calculator to see this as one term. So that will be 1.25, which is 1 1/4 cups of butter. I'm going to say over 1 1/4 cup, okay, of butter. Now, same thing if I was set up as for proportion, 4 dozen cookie for 1 2/3 cup, set equal to 3 dozen cookie for X number of cup of butter. So the 4 and 3 means the dozen cookie, denominator representing the cups of butter. So if I use a cross product, 4 times x is 4x. Set equal to 1 and 2/3 times 3. So let's see what 1 and 2/3 times 3 is. So parenthesis 1 plus 1 divided by 3, close it, times by 3. So that's 4. All right, divide both sides by 4. Let me make sure I'm typing it right. 1 and 2/3. Oh Lord, 1 and 2/3. I'm typing it wrong. No wonder. 1 plus 2 divided by 3 times 3. Right, 1 and 2/3 times 3. I just entered 1/3 instead of 2/3. All right, that's 5. All right, divide both sides by 4. 5 divided by 4, which is 1.25 again. All right, or 1/4 of a cup. So either technique will work, okay? So I'm going to go with my original technique. I was going to make 4 dozen. Now I only need to make 3 dozen. So what I need is 3/4 of my original, of 3/4 of what my recipe is calling for. So let's do baking powder. I just need 3/4 of it. So that will be 2.5 times 3/4. So I know 2 and 1/2 is 2.5. So that just makes it. So tapping the decimal here makes it easier. Times by 3/4, which is 0.75. So that's 1.875. So if I want to convert into a mixed number, that will be 1 and, so I know my whole number is already 1, so I'm going to take away 1, convert my 0.875 into a fraction, which is 1 7/8. Okay, teaspoon of baking powder. Now, why don't I do the same thing using decimal for 1 and 2/3? Because I know 2/3 is 0.6 repeating, which is harder to key in. That's why I just went with the mixed number for 1 and 2/3. All right, just like my pecans, 2 and 1/3 cup of pecan. 1/3 is 0.3 repeating, so I'm just gonna type this 2 and 1/3 in as a mixed numbers. And I now need 3/4 of the ingredient. So parenthesis 2 plus 1 divided by 3 times by 0.75. Or you can type in 3 divided by 4. Either way will work. 1.75. 1.75 is the same as 1 3/4 cups of pecans. All right. So just using proportions. Okay. To do a couple example of cooking and decreasing in annual pay here. So proportion is very, very common. Students have different ways of solving proportions, okay? But I at least want to set it up at one time to show you how we can set them out as proportion and solve for x. All right, that will conclude this lecture video on proportion. We will do more proportion in other sections of chapter 4 as well. All right, so that will conclude this lecture video. Thank you for watching.